All right, welcome to Pre-Calculus, Day 3 notes on Section 5.5. So today we'll be looking at examples 7, 8, and 9, and then finally tomorrow we will actually finish up on lesson 5.5. So there is quite a bit of formulas in this one, so it's good to take a little bit at a time. So first thing first, to remind you, we just took a look at half-angle formulas, which are going to look like this. So now the reason I'm reminding you of this is on example 7, we're going to involve one of these half-angle formulas. So if we take a look at example 7, it says find all the solutions of this interval right here. Okay, so first step, a good strategy is to get these all to the same trig function. So for instance, we could either have all sines, we could have all cosines, so on and so forth. So first step, if I notice that there is something that is over a 2, so x over 2 on the right side of this equation, I'm going to go ahead and I'm going to use my half-angle formulas. So I'm going to go ahead and replace this cosine squared and then x over 2 with one of my half angles. The 2 would stay out front. I can't mess with that yet. All right, so if I do that, I look at my cosine half angle. Now, it is squared, and if you remember correctly, that means that the whole thing is squared on the outside. So I'm going to do that after I am done writing this cosine half angle formula. So I have the square root of 1 plus cosine x, and this is all over 2, and then our squared on the outside. Now, if you have a square of a square root, most of you know that you can take that out. The sine value, plus or minus, would also disappear. So we'd have 2 times, this comes out, so it'd be 1 plus cosine x over 2, and of course that is all now out of the square root. So the final thing we can do on the right side is to go ahead and simplify. So we can cross out the fraction, the 2's. Okay, so I have 1 plus cosine x left over. Now, I'm going to bring down the second part here on the left side, which we haven't touched yet. So that is what we have so far. Now, we still have an issue here, which is we have a sine, we have a cosine, and they're on opposite sides. So we do need to get these both to cosine now. And the reason I know that is because sine squared x is an easy Pythagorean identity, which you guys have used throughout this entire chapter. So I'm going to replace this sine squared x with 1 minus cosine squared x, and then I'm going to leave that right side alone. Okay, so simplifying. I'm going to first take this negative through, and yes, you're going to definitely want to leave yourself some space. This is a rather large problem with actually a pretty simple solution once we get through this. So take the negative through on the left side, so I get 2 minus 1 plus cosine squared x, and then 1 plus cosine x, I'm also going to move that over to the left side, because once I get all cosines, whoops, I know that I can either factor or I can put them together and cancel some things out. Okay, so I moved everything to one side. I have 2 minus 1, which is 1, and then minus another 1. So these are actually going to all cancel out, these numbers. And then I just have cosine squared x minus cosine x. Okay. So once we get that far, you can notice, well, you can factor out a monomial here, which is cosine x, and then it'd be cosine x minus 1, and that would be equal to 0. All right, so next thing, if I go ahead and I do this, I can set cosine x equals 0, and then if I solve this one here, I get cosine x equal to 1. Now, remember the interval is between 0 and 2 pi, so all I have to do is check where cosine equals 0, which is going to be at pi over 2. It's also going to be at 3 pi over 2. All right, and then you got to check where it equals 1. So the next spot, to determine if you put 0 or 2 pi here, go back to your interval Whoops. Okay, notice how you can have 0, but you can't have 2 pi, because it is a parenthesis at 2 pi, which is open, so therefore, I also write 0. So you have 3 answers here, pi over 2, 3 pi over 2, and you also have 0. During the class period today, we'll go through the calculator. You can check these on the calculator. You put these both in and then see where they cross each other. And that is the second intersect feature if you would like to check that out. Of course, this is our algebraic version, which I prefer. So, next one. It says product to sum formula. So another formula we'll introduce here, just product to sum. So if you ever have 2 different trig functions, sine and cosine, you can write these out as sum formulas. So it makes it pretty obvious in the examples, and it also makes it pretty obvious in your homework. It'll say product to sum formulas above it. So you definitely at least have an inkling as to what to use. So let's take a look at it. First off, we have cosine 5x and then sine 4x. Let me grab my formulas here. And it says rewrite the product as a sum or a difference. So really the only goal here is to get them to a simplified sum or a simplified difference. So you don't need to solve anything here. You're just simplifying it as a sum or difference. All right. So first thing first, if we have cosine 5x and then sine 4x, you might notice that they bring in the u and the v again. So we'll make this u, we'll make that v. All right. And of course, they just list them u, v like it is in the alphabet. All right, so if you check them, it is going to be the 4th one down. So it's going to be this one here, which is both signs. You also have a 1/2 out in front. So I'm just going to go ahead and fill this in. So it's equal to 1/2. It would be sine u minus v, or u plus v. So it would be 5x plus 4x, and then it would be minus sine, and then it'd be u minus v, so it'd be 5x minus 4x. And then we all have 1/2 on the outside. So you may notice they use parentheses, and they use brackets on the outside of this equation. All right, so simplifying this, you can add the 5x and 4x, so we would get a 9x on the inside, so we get sine 9x, okay, and then we get minus sine x. Okay, so if I were to simplify this a little further, I can take the 1/2 through, which is sine 9x over 2, and then minus sine x also over 2. Okay, so there, I'm going to fill this in. There is your sum that you would find would equal, whoops, the same exact thing. I put an S there, so it would be 4x. Okay. There is your simplification. It is a difference. Okay, so let's take a look at our last example here. The last example, whoops, here. All right. So sum the product again. Again, you have just a different type of one. This one starts with sum, and then this one ends with product. So if we want to go sum to a product, vice versa here, you again have a different formula. So notice how they use u and v again, and it is another formula being thrown at you. These are all found in your the front of your book in the different the formulas. All right, so if you forget all these and you're looking, you don't have to page through your notes. You definitely can check the front of your book. Excuse me. All right, so let's go to our next example. After I grab a quick drink here. All right, so excuse me. We have a cosine and a cosine, so we'll name this u, v. All right, so 195 is u, and then 105 is your v. All right, so this would fit the third one down, so it would be this one right here. All right, and then basically all I got to do is look at the formula and fill it in. So I'm going to do that. All right, so cosine 2 cosine u plus v, so I go 195, 105 over 2, then it'd be plus, or excuse me, times, that's what we're trying to avoid there, is plus, and then it'd be u minus v, so 195, and then minus 105. So we are actually trying to find an exact value of this. So our goal here would to be replace these with what they're equal to, the outputs. So that is our long-term goal after we go ahead and add the subtractor. All right, so 2 times your cosine, 195 plus 105 is 300, and then you do have to divide that by 2, so this is 150. All right, and then cosine over here, 195 minus 105 is going to be 90 over 2, which is 45. All right, and then you replace them. So 150 cosine, which is the x value at 150, is negative square root of 3 over 2. And then the next one would be 45, so we're looking at the square root of 2 over 2. Okay, and then you just have to simplify. Now, 2 times one of these, you can cancel out one of the denominators, and then you can multiply the 2 numerators. So if you have 2 square roots, of course, you can multiply underneath the square root. So we would just have negative square root of 6 over 2. Now, what this is doing is it's giving you an arsenal as to which to solve lots of different types of trig functions. So it's very useful when you get to calculus, or say you have a type of application problem. You have many different ways to solve it. There isn't just one way to solve it. And that's really what this section is about, is showing you multiple ways to solve things. And then it's kind of up to you. But again, your usefulness of this is look in the front of your book, and you definitely have all your identities, you have all the formulas, and that'll be very helpful. So what we'll do tomorrow, since there is a lot thrown at you here, is we'll try to go through example 10. I see I have some things written down there. We'll go through example 11, and we'll go through this example 12. And then that will be the end of the chapter. Have a great day.